Okay, we are done looking at titration curves for acid-base titration. So that was a lot of titration curves. And now we're moving on to when we're actually doing a titration, how do we find the endpoint? So you've done this, and you've done this before, but let's talk about the choices that go into this. So there's generally two approaches for acid-base titrations to determining the endpoint. One is to measure the whole titration curve and use a pH electrode to do that. So if we can measure the pH, then we can plot out this titration curve. And one nice thing, one advantage of this is if you want to find pKa values, this also allows you to determine that because you can get the pH at the halfway between the equivalence point, in that buffer region. Okay, so we can use, so this is our first option, is to measure titration curve with the pH electrode. And so, essentially we're just going to map out the pH versus volume curve. We'll measure the pH as we do the titration. It's a little bit of a painstaking process, but we map it out, right? And so you'll get something, like looks like this. Now, this doesn't directly give you, right? How do you determine what is the exact equivalence point, or what do you call your endpoint in here? And so we need to find a way to specifically find this. And so we can use properties of titration curves to look at this. And so I'm going to switch over to PowerPoint real quick to a couple of figures from your textbook. So, this is an example of, you'll get something like this as a titration curve. It looks like my toolbar stayed at the bottom, whatever. And so, like I mentioned, at the halfway to the equivalence point, we can find the pH equals pKa. But we can also look at what's happening with our derivatives, and what's happening with the slope of the curve at different points here. So at the half equivalence point, that's our minimum slope. So if we took a derivative of this, this would be the smallest value we'd get. And at the equivalence point, we get an inflection point. So we get this is where the maximum slope is. In this case, it'll be a positive slope if we have, so this is a titration of a weak acid. If we had a titration of a weak base, it would instead be a minimum slope. It would be a negative slope. But either way, it's the largest value right at the equivalence point. And that also means, since this is an inflection point, the second derivative is 0, right? So the derivative of the derivative goes to 0 at the equivalence point. So we can take advantage of those two facts to find our equivalence point. So you can either do it with the first derivative or the second derivative. And so this is an example of how you might do this. So this is some experimental data for a diprotic acid titration. So this is hexaprotic, not diprotic. So we really only see 2 of the 6 equivalence points. So this is as I mentioned, a common thing with polyprotic acid titrations. But we can see these equivalence points. There's this sharp curve here and here, and what's done here is that we've plotted the first derivative, and we can see this increases to a maximum. And so we can visualize these 2 equivalence points much more clearly. And in the second derivative, we get a 0 crossing here. And we can take that 0, that place where it crosses 0, and that is our equivalence point. Now, how we actually do this is outlined in your textbook. And this is the basic idea here, is that you have your data points. So this is your original data, volume of, in this case, sodium hydroxides in microliters. This is probably using an auto titrator or something, and your pH. And then you can find the first derivative by taking the difference, right? The difference in the pH divided by the difference rate. A derivative is change in y over change in x. So our change in y is the difference in pH divided by the difference in the volume, and we can use that to find approximate a value of the derivative here. So, this isn't exact, but with the data we have, it's what we can do. And since this derivative is between these 2 points, our x value we take to be halfway between. So 85.5, since it's between 85 and 86. We can repeat that same process to find a second derivative, and you'll do this for a homework question that you have, as well as for one of your labs. And so there's formulas down here that show how to do this. But when you actually, plot out the titration curve, this is the idea behind what you're doing, is that you want to find you want to use these properties of derivatives to get exact values instead of eyeballing it and say, oh, it's roughly here. You want something more quantitative than that. So you can use the first and second derivative plots to guide your analysis to find the endpoint. So that's the first way of finding an endpoint. The second way is indicators, which we'll talk about in the next video.